Hello and welcome to the Unit 3 Section 2 video on functions, relations, and data sets. So we're going to start off by talking about what a relation is. A relation is a mathematical way to relate one variable to another. Okay, so we are not being all that too clever about how we name these things. A relation is how we relate things to one another. For example, we can relate the variables y and x and say that y equals 3x. That is a relation. The domain is the set of all x values. And the range is the set of all y values. So now we have some of that basic information. Let's talk about representing relations. So we can do this several ways. We can do it using a table, a graph, or a mapping. And a mapping may be fairly new to you. So let's start with a table. That's fairly straightforward. In a table, we're going to have our x values and our y values, and we're going to take our sets of ordered pairs, and we're simply going to list them. So we have 1, 2, 4, and 2. I'm going to go ahead and put our x's in numerical order. Okay? So with 1, our y value is 1. With 2, our y value is either 1 or 6. And then with 4, our y value is 5. And so here they are graphed. Okay, I'll kind of highlight those here for you. We went over graphing in Unit 0, so I think you are fairly aware of how to graph sets of ordered pairs. Then in a mapping, we're going to put our x values and our y values each in an oval of sorts. Okay? Now here's an important thing to note. You only have to list each value once. So even though we have two x's that are value 2, we only have to list it once. So here we're putting 1, 2, and 4. And then for y, we have 1. We don't have to list 1 again. We have 6 and we have 5. So what you're going to do is you're going to draw an arrow going from one value to the next. So we have from 1 to 1. So 1 to 1. Okay. And it's important that you put an arrow on the right-hand side. Now for 2, we have 2 going to 1. So we have 2 arrows going to 1 here. But we also have a 2 going to a 6. So we're going to draw another arrow like that. And then we have 4 going to 5. Now you can think of the x and the y as your input and output. These are our input values. And our input values lead us to our output, which is our y. All right, let's do another example of this. So here we have the ordered pair 0, 0, negative 3, 2, 6, 4, and 1, 1. So let's put our x's in numerical order. So we've got negative 3, 0, 1, and 6. So with the negative 3, we have a 2. With the 0, we have a 0. With the 1, we have a 1. And with the 6, we have a 4. So let's graph these. So when we do the graph of these, we are going to end up with negative 3, 2, 0, 0, 1, 1, and 6, 4. So there's your graph of these 4 points. And now in the mapping, we're going to do all of our x values once. So we got negative 3, 0, 1, and 6. And we also have 2, 0, 1, and 4. We have no repeats, so we end up just listing everything. And now let's draw our line from -3 to 2, from 0 to 0, from 1 to 1, and from 6 to 4. And that would be it for this one. In the next example, we've got our x values and our y values. We've got 1, 2, 3, 4. And our y's that go with it, 3, 4, 3, 4. So when we graph it, it's going to look like this. We have 1, 3, 2, 4, 3, 3, and 4, 4. And then our mapping, we are going to have 1, 2, 3, and 4. Those are our x values. Our y values are going to be just 3 and 4. And then we're going to draw our lines from 1 to 3, 2 to 4, 3 to 3, and 4 to 4. Now in these boxes on the bottom, we're going to list out what our domain and range are. So let's start off with the domain. Recall the domain is all of your x values. So your x values are going to be 1, 2, 3, and 4. For the range, we are going to list all of our y values. And you do not have to repeat when you're doing your domain and range, so it's going to be 3 and 4. Since we don't repeat, notice that our values for our domain are just simply pulled out of the x values for our mapping. Our range values are just simply our y values pulled from our mapping. In the next example, we have x values of we have x values of 5, 5, 3, and 0. So in numerical order, 0, 3, 5, and 5. And our y values that go with it, with the 0, we've got -2. With 3, we've got -2. With 5, we've got 2 and 6. So let's plot these. 0, -2 would be here. 3, -2 would be here. 5, 2 would be here. And then 5, 6 would go here. So our x values are 0, 3, and 5. Our y values are -2, 2, and 6. So we have 0 going to -2. We have 3 going to -2. We've got 5 going to 2. And we have 5 going to 6. As far as our domain goes, that's going to be all of our x values. And again, one of the easiest places to pick this up is by just looking at your mapping. So our domain is going to be 0, 3, and 5. And our range is going to be our y values, which would consist of -2, 2, and 6. All right, let's talk about functions. A relation that has only one y value per x value. So it only has one y per x value in the set. The x does not repeat. The y can repeat. So we're going to determine if things are a function. Remember, the x cannot repeat. It doesn't matter what the y does. So for this one, since we have no y values repeating, we can say set S is a function. For t, we have the x value repeating. The value 1 repeats, so we can say that set t is not a function. All right. For the mappings, you're going to look to see if your x goes to two different y's. If we have an x going to two different y's, that means our x repeats. So here, not a function. But this one, we only have one line going from each of the x values, so this one is a function. Taking a look at tables, again, if we have a repeating x, which we do here, then we can say this is not a function. This one, no x's repeat, so we can say this one is a function. Now, when we talk about graphical representation, we can write as a set of ordered pairs. So let's write what is in this graph as a set of ordered pairs. So we have -1, -3. That's that first left-handmost point. Then going to the right, our next point is 1, 6. And then our next point after that is 5, -2. And then finally, our point after that is 5, -3. So, do we have any x values that repeat? Well, we do. There's 2 5s, so therefore, t is not a function. For graphs, we use the vertical line test. So if I were to take a vertical line and pass it through here, so let's say I draw this vertical line. And if I were to take this vertical line and pass it from left to right, if we see 2 points go through that line at the same time, like we do here at 5, then it fails the vertical line test and it's not a function. But as long as we only have 1 point going through this vertical line as we pass it from left to right, then we have a function. And this one is not, again, because we have 2 points going through it. Okay? So let's take a look at these 3 graphs and see if it passes or fails the vertical line test. So here's my vertical line, and I'm going to pass it through. So if I pass it through, we've got 1 point there, we're good. 1 point here, we're good. Another 1 point. Again, 1 point, 1 point, 1 point. So at no place do we have 2 points going through at the same time. So this one, we can say, is a function. All right, let's take a look at the next one. Here's our vertical line again. And if we pass it through, immediately we have 2 points going through this vertical line at the same time. So we don't even have to go any further. We can say that this line is not a function, or this graph is not a function. And finally, let's take a look at the last graph. Here's our vertical line again. As we pass it through, you notice at no point do we have the line crossing our vertical line twice. And so since we don't cross our vertical line twice, we can say that this one is a function. All right, so that pretty much brings us to the end of section 2. Coming up in the next section, we're going to talk about discrete versus continuous functions, and we're going to delve a little bit more into domain and range.